Hello everyone. In this video we are going to talk about logarithmic functions. To begin with, let's consider an exponential function. Let's say y is equal to 10 to the power of x, okay? Which is equal to 30. Then we are supposed to find the value of x. What is the value of x? Well, then we know that if we raise 10 to the power of 1, we will get 10. And if we raise 10 to the power of 2, we will get 100. Therefore, this x should be somewhere between 1 and 2, okay? Less than 2 and larger than 1. But we don't know exactly what is the value of x. In order to find the approximate value of x, we need to plot this graph. We need to plot the graph of y is equal to 10 to the power of x, and then we can find the value of x when the value of y is at 30. So okay, in that case we will give random values to x by using the ordered pairs and coordinate axes. So we just give random numbers to x such as 1, 0, 2, and so on. And then we will find the value of y, and then we can plot this graph. So this is the graph. And then here at 30 we can find the value of x, which is 1.48. Therefore we can say here the value of x is 1.48, okay? But not always we need to plot the graph in order to find the value of x in such cases, okay? There is a function that gives the value of x directly. So, and that function is log 30 to base 10, which will give us the value of x, okay, which is in this case is 1.48. all right? So this function is called logarithm or logarithmic function. This function that gives the value of x directly, okay? We can calculate and then we can find the value of x by using a calculator, okay? So then by comparing these two functions, we can conclude that if 10 to the power of x is equal to 30, then x will be equal to log 30 to base 10. So notice that this 10 is down left side below the number. So this number 30 is exactly in front of log. So it's not the index of 10. 30 is not the index of 10. It's just the number in front of log, which is the abbreviation for logarithms. All right, so we can conclude that, okay, we can conclude this: if 10 to the power of x is equal to 30, then x will be equal to log 30 to base 10, okay? Then we can calculate the value of x by a calculator. By a calculator we can find the value of x, or if we change this 30 to 40, for example, again we can find the value of x by using a calculator. And any numbers, any value for y, which stays here, this is y, yeah, this is y. or fx. So then we can come up with a general expression when comparing an exponential function and a logarithmic function. We can say, if we can conclude like that, if y is equal to, let's say, any number to power of any number or a variable, then we can conclude that the power b will be equal to log y to base a. This is what we need to conclude. This is the relationship between an exponential function and a logarithmic function. So we can then convert a logarithmic function to an exponential and exponential to a logarithmic function by using this relationship, right? Okay, so now if we are asked to, let's say, draw this function, if we are asked, suppose, to draw this function, y is equal to log x to base 10. How to plot this graph? In order to draw or plot this graph, we first need to convert this logarithmic function to an exponential function, and then from there we can easily give random values to x or y and then find a value for the other variable and then plot the graph on the coordinate axis. So let's say I will convert this logarithmic function to, so where is the base? The base here is 10. So here the base log x to base 10. So here is the base. So I will write base here, okay, 10. And the number which appears on the other side of the equation, which is y here, will be the power, and it will be equal to the number which is in front of a log or logarithm, and that is x. Okay, so then this is the exponential form of the function above. Okay, so then now I can give random values to y and find the value for x. So I can say if y is 0, then x will be 1. If y is 1, then x will be 10. If y is, let's say, negative 1, then x will be equal to 0.1. Okay, so this is the way how we can find the ordered pairs on the coordinate axis. And the next step is easily we can plot the graph. So this is x and here is y, coordinate axis. So the first order pair is x is 1 and y is 0. So here is the first ordered pair. And then the next one, x is 10. Let's say here x is 10 and the y is 1. Okay, y is 1. Here is this next, and the third one, y is negative 1 and x is 0.1, which is somewhere here, 0.1. So this will be the next point. And as you see, as y negatively increases, the value of x approaches 0 or become smaller and smaller. They will become smaller and smaller. So therefore we can draw this graph, which is something like that. And that is the graph of y is equal to log, okay, x to base 10. We are done. We already drew the graph. So what we did is we first converted the logarithmic function to the exponential function, and then we could give random values to y because y was the power index of the 10. Then we could get the values or obtain the values for x. All right, so now let's do some exercises here. We need to convert this exponential. You see there are 3 exponential functions and we need to convert it to logarithmic form. Okay, so again, from the relationship that we learn above here, we need to use this relationship or rule to convert these exponential functions to logarithmic form. So therefore here, for example, first of all, the first step is always to identify the base. So here the base is, here is the base is 10. Okay, so I will write log and I will put 10 here. So I already got rid of the 10, and then I know this tree, the index will appear in the other side of the equation or function 3, and then this number which is in the on the other side of the equation will appear in the front of the log. Okay, so this is the logarithmic form. Next one, again, what is the base here? 10. So I will write log base 10, and what is the power here or index is x, so x will appear on the other side of the equation, the power or index, and then the number on the other side of the equation will appear in front of the log. Okay, so similarly this one, where is the base? Base is 2. I will say log to base 2. First I will write base. Actually we need to first write the number and then to base, but this is an easiest way to identify the base, and then according to the base we can convert the exponential form to logarithmic form. All right, so and the power will appear on the other side of the equation or index, and the last step is to put the number or the variable, whatever it is, on the other side of the equation in front of the log. That's it. Okay, and next one is we need to find the value. What is the value? Value of the following. So what is the value? So in order to find the value of these expressions, because we don't know the value, let's set it as x. Okay, let's set it as x. And notice that whenever a logarithmic function doesn't have base, so base is not shown, you need to take it as 10. So 10 is not written most of the time, so this is 10. So therefore I can say, where is the base? Base is here, 10. So I will write 10 as the base, and then remember the other side of the equation, whatever it is, appears as the power x and will be equal to whatever is in front of the log will appear on the other side, and that is 10 to the power of 1 over 3. This is the way we need to write. We can write the radicals, so then, or cubic roots here. So then we can compare. Bases are the same, powers must be equal. Therefore, x is equal to 1 over 3. So this is the value of x. Next one. Again, we set it to x because we don't know the value. So we will say base is not given. So that means it is 10. So I will write 10. And whatever is other side of the equation, we will take it as x, okay, is equal to, and whatever is here in front of the log will appear the other side of the equation, which is 10 to the power of negative 2 here in this case. Therefore, notice that we need to write this number in a form similar to the what we have already got on the left side, okay. So therefore, according to the comparison of these two numbers, bases are the same, powers must be the same. X is equal to negative 2, okay. And here we need to convert from logarithmic form to exponential form. So therefore here I will write the base again one more time. What is the base here? 8. 8, whatever on the other side of the equation appears as the power is equal to 2. And actually that is correct, yeah. And the next one, again, where is the base? Base is x. So x, whatever other side of the equation appears as the power is equal to 8. And this is another exponential 4, okay. All right, but there are some rules also that help us to simplify logarithmic functions. There are some rules, and the rules are here. Rule number 1, well, there is no sequence here, but just we can say, like, this is the first one. Whatever log of a number or a variable, when it has the same base, the value will be equal to 1. And log of 1 to any basis will be equal to 0, because any number to the power of 0 will be equal to 1. If we write it in an exponential form, it will be a to the power of 0 will be equal to 1. And this a can be any number or variable, okay, it doesn't matter. So log 1 to any basis will be equal to 0. And also, if we have a log of a number which has a power, is exponential, and this number, the base is the same as the base of the log, the value of this function will be equal to the power of the exponential number. It will be b. And also the next one, which is very useful, if we have two logarithmic functions with the same basis, base a, so when they are when there is an additional sign and they are added up together, we can write it as a one function with the same base but multiply. We need to multiply this number and just set one log. And next one, if we have two logarithmic functions which they have the same base, and one is subtracted from the other, okay, so then we can write it as one function which the positive one divided by the negative, okay, x, which is here, divided by y. And this rule, which is similar to what we talked about already, they are similar, but this power, the power of the number which is in front of the log, can move behind the log, Okay, this is a very, very interesting property of logarithms. So this b can move and can be written in the back of the function. So now, by using these laws or rules, let's solve some problems. So here we go. We have this problem and we need to solve. So the first step is we see a number behind the log, and it's making it more complicated because the other one doesn't have any number, so we want to simplify. Okay, therefore I can just put this number as a power to this 25. So I can write it like log 25 to the power 1 over 2 to base 3 plus log 4 to base 3. And we know 25 to the power of 1 over 2. Power 1 over 2 means square root. Yeah, power 1 over 2 means square root. So 25 to the power 1 over 2 will be equal to 5. Therefore, it is equal to log 5 to base 3 plus log 4 to base 3, which is equal to log 20. We need to multiply this 4 by 5 to base 3. And this is the final answer. We cannot simplify further, okay? Because we are supposed to just write it as one logarithmic function here in this part. Okay, and the next one, you see again there are two numbers behind the log. Okay, so then I will transfer each to the as a power, as the index of the number in front of the log. So I will write log 4 to the power of 2 to base 7 minus log 2 to the power of 3 to base 7 will be equal to log 16 to base 7 minus log 8 to base 7, which is equal to log, according to one of the rules and properties of logarithmic functions that we studied earlier, will be equal to divide. We need to divide 16 by 8, so it will be 16 over 8 to base 7, which is equal to log 2 to base 7. So this is the final answer, which is written in one logarithmic function. And the last one, which is 3 minus log 10 to base 4. How we can write it in a single logarithmic function. So we see here there is a number, so it's not a logarithmic function. Before, whatever we studied about, they were all logarithmic functions, but this one is only a number. So how to subtract this logarithmic function from 3? Then we can use the properties of logarithm that we already talked about here, which any log of any number to the same base is equal to 1. And again, here any power that can be appeared on the behind of the logarithmic function. So I can write it like this. 3 can be written as 3 times log. I will select base 4 because the other logarithmic function has the base 4. Okay, so I will choose base 4, and this number should be 4 because log 4 to base 4 will be equal to 1, and 3 times 1 will be equal to 3, minus log 10 to base 4. Therefore, again, we can simplify it further, which is equal to, now I can take this 3 as the index or the power of 4. So I can write it as log 4 to the power of 3 will be equal to base 4 minus log 10 to base 4. So 4 to the power of 3, we need to raise 4 to the power of 3, which will be equal to 64. It will be equal to log 64 divided by 10 to base 4, which is equal to log 6.4 to base 4. And this is a single logarithmic function that we solve. We simplify this function to this function. Okay. All right. Thanks for watching this video. Please like and subscribe if you found this video helpful.